Kubernetes autoscaling adjusts the number of pods or nodes or their sizing in response to runtime conditions. Kubernetes provides several mechanisms for autoscaling, each serving a different use case. Let's dive into how Kubernetes autoscaling works.
Horizontal pod autoscaling. The horizontal pod autoscaling, HPA, enable Kubernetes to automatically adjust the number of pods in a deployment or replica set based on observed metrics such as CPU utilization or other select metrics. By fetching metrics and comparing them with threshold value configured in the HPA, if the metric value shows that the upper threshold is exceeded, for example, we do configure a threshold of 90%, the HPA triggers the increase of pod replicas. The opposite happens when we configure the lower threshold, for example 10%, which will be used to decrease the number of pods. Vertical pod autoscaling, VPA. The vertical pod autoscaling is used to adjust the CPU and memory requests of individual pods, ensuring they have enough resources to operate effectively without over-allocating. Following the same approach as the HPA, exceeding a certain threshold, it triggers the VPA to increase the allocated capacity for the pod, and by falling below a certain threshold, it decreases the allocated capacity to the pod. Cluster Autoscaler, CA. The cluster autoscaler automatically adjusts the size of the cluster, adding or removing nodes based on resource requirements and constraints. This enabled by monitoring the pod deployment. Once a pod is being failed to deploy due to insufficient capacity, the cluster autoscaler request for the creation of a new worker node. The same way, if it finds that the utilization in a worker node is lower than a certain threshold for a certain period of time, it will terminate the node and evict the existing pods to other worker nodes. Now, an important question needs to be raised. Can we mix and match between all the autoscaling features? The technical answer yes, but better no. Mixing HPA and VPA can lead to issues if it is not well calculated. When using both VPA and HPA, there's a risk of them conflicting. For example, HPA might try to decrease the number of replicas because it notices a decrease in CPU or memory load, while at the same time VPA could be trying to increase the resource requests of individual pods. This could lead to unstable behavior. We can use both CA and HPA. Let's suppose we have a sudden spike in traffic. HPA will scale out the number of pods to handle the increased load. If the current nodes are fully utilized and no more pods can be scheduled, the CA will recognize this and add more nodes to the cluster. This combination ensures that your workloads can scale out to meet demand and that there are sufficient nodes in the cluster for those workloads to run. But this combination have also drawbacks. This combination can lead to increased costs if not monitored and configured correctly. For instance, if the CA frequently adds and removes nodes, it can lead to increased costs and potential disruptions.